How are you all? So welcome to Mona Patil tutorials. Today we are going to learn about very important and interesting chapter which is acid, base and salts of standard 9 Science and Technology Maharashtra board. This is part 1 of this chapter. As this chapter is very big, we will complete this chapter in two videos. If you have not subscribed my channel, then please subscribe and press on the bell icon. Student, this is very important chapter, so watch the complete video and share this video with your friends. So let's start acid, bases and salt. So which topic we are going to complete in this lesson are Arrhenius theory of acid and bases, concentration of an acid or a base, pH of a solution, pH of an acid and a base, and last is the salts. Okay, then already you have learned the topic. We have earlier seen that some foodstuffs are sour to taste while some other are bitter and slippery or soapy to touch. So when these substances are studied scientifically, it is found that they contain acidic and basic substances respectively. We have also learned an easy and safe method of using an indicators like litmus to identify acid and base. Now here the table is shown here. This table contains columns. In the part A of the following table, you can see here name of compound, molecular of formula, basic radical, acidic radical and type of compound. As you will complete this table, you will come to know about the types of acid, bases and the example of salt. So here they have solved one for you and remaining we will see some of them and the rest you can complete. Okay. So first is, this is what? A nitric acid. So here name will come nitric acid. From nitric acid, here H plus and NO3 minus. Okay. And here will come acid. So from this we can come to know the compound leave the basic radical as a hydrogen ion, then it is the acid. Okay. So here hydrogen bromide, sulfuric acid, then these all examples are what release the H plus ion as the basic radical and that's why they are acid. Now from NaOH and KOH, here sodium hydroxide and KOH the potassium hydroxide. So here Na is the basic radical Na plus and OH minus here is the acidic radicals. Here K plus is the basic radical and OH minus is the acidic radical. So the compound which give the acidic radical OH minus, they all are base. So here other example of base is given, calcium hydroxide, ammonium hydroxide, like this. Okay. The next, these are the salt. So here instead of H plus ion, there will come Na plus and instead of OH minus, there come Cl minus. Okay, so there is no H plus, no OH minus and rather than it, other basic and acidic radicals are present and such a compound is called neutral type of compound and they almost all are salts. Okay, then acid, base and salt. So from given table, we come to know about some compound are seen to have H plus as the basic radical in their molecule. These are all acid. Some compounds are seen to have OH minus as the acidic radical in their molecule. So all these compounds are bases. And third, those ionic compounds which have a basic radical other than H plus and an acidic radical other than OH minus are called salts. Okay. Then next, ionic compound recapitulation. So we have already studied about the ionic compound. So here we'll just revise about it. So the molecule of ionic compounds have two constituents, namely cation, ion or basic radical, and anion, negative ion or acidic radical. So there is a force of attraction between this ion as they are oppositely charged, and that is called ionic bond. So bond formed by two acidic and basic radicals ion, this bond is known as ionic bond. The force of attraction between one positive charge on cation and one negative charge on an anion make one ionic bond. Okay, so here you can see in the diagram, here sodium electronic configuration 281. So in outermost shell there is a 1 electron. As we know, the metal have the tendency to give the electron. Okay, so here 1 electron is leaving from the sodium and the electronic configuration of sodium become 2,8. Now those 1 electron are leave that have received by non-metal like chlorine. Chlorine have the electronic configuration 287. So outermost shell need 1 electron to complete the octave, and that is why the electron leave by the sodium is received by chlorine and the electronic configuration become 288. In this way, sodium and chlorine share 1 electron to form one bond with them. Okay, and this bond is the ionic bond and form the sodium chloride as a salt. Okay, so here this sodium chloride have high stability because they share 1 electron and both the elements complete their octave. Okay, then next, dissociation of ionic compound. So on dissolving in water, an ionic compound form an aqueous solution. Aqueous solution means solution of some solute in the water. Okay, if water is mixed, then it is aqueous solution. So in the solid state, the oppositely charged ion in the ionic compound are sitting side by side. Okay, so here in a drop you can see this drop of salt contain two molecules, chlorine and sodium, and they are very close to each other. Okay, but as it will mix into the water, these ions are go far away from each other or move far away. Okay, so this is what a dissociation. So when an ionic compound being to dissolve in water, the water molecule push them in between the ion of the compound and separate them from each other. So in this way they separate, and in the next diagram you can see chlorine and sodium are not attached to each other or not close to each other, they are far away from each other. Okay, so that is to say an ionic compound dissociate while forming an aqueous solution. So this is the aqueous solution of salt. Okay, and next, Arrhenius theory of acid and base. The Swedish scientist Arrhenius put forth a theory of acid and base in a year 1887. This theory gives the definition of acid and base as follows. So whatever the term you have learned here, this all term is help you to understand this. So an acid is a substance which on dissolving in water gives rise to H plus ion as the only cation. Okay, so such examples are acid. Here given example as hydrochloric acid, sulfuric acid and hydrogen carbonate. Okay, so here after dissociation you can see here each compound give rise to hydrogen plus ion. Okay, so these all are acid. Now base. A base is a substance which and dissolving in water give rise to the OH minus ion as only anion. So in acid you can see the cation has given hydrogen cation, and here OH minus anion. Okay. So example of base are sodium hydroxide and calcium hydroxide. Okay, so here you can see at the end of the product the OH minus is the anion. Okay, so here these are the base. Now the type of acid, base and alkali. So classification of acid, base we can see here: strong and weak acid, base and alkali. So strong acid, weak acid, strong base, weak base, and fifth one is the alkali. Okay, so first acid and bases are classified into strong and weak type on the basis of the extent to which they dissociate in the required solution. Strong acid first. So on dissolving in water, a strong acid dissociate almost completely. Okay, completely it will dissociate it. Nothing particle you can see. No particle you can see in the solution. And the resulting aqueous solution contain mainly H plus ion and the concerned acidic radical. For example, hydrogen chloride, hydrogen bromide, nitric acid and sulfuric acid. These all are strong acid. Now weak acid. So on dissolving in water, a weak acid does not dissociate completely and the resulting aqueous solution contain H plus ion and the concerned acidic radical in small proportion along with large proportion of the undissociated molecule. Okay, so of the acid, and for example here hydrogen carbonate, then acetic acid is the example of weak acid. Then next is strong base. On dissolving in water, a strong base dissociate almost completely and the resulting aqueous solution contain mainly hydroxide or OH minus ion and the concerned basic radicals, for example NaOH sodium hydroxide, KOH potassium hydroxide, calcium hydroxide and sodium oxide. These are strong bases. So next is weak base. On dissolving in water, a weak base does not dissociate completely and the resulting aqueous solution contain a small proportion of hydroxy ion or OH minus ion and the concerned basic radical along with a large proportion of undissociated molecule of the base. The example is ammonia hydroxide or NH4OH. Now last one is the alkali, and it is very interesting. You can see here the base which are highly soluble in water are called alkali. Here this line is very important. The base which highly soluble in water is called alkali. An example given NaOH, KOH, NH3 means sodium hydroxide, potassium hydroxide and ammonia. Here NaOH and KOH are strong alkalis while NH3 is the weak alkali. And from this sentence we can infer that all the alkalis are base. Okay, but all the base are not alkali. Okay, the next is basicity and acidity. Here number of H plus ion obtained from one molecule. So here hydrogen chloride, nitric acid will give only one hydrogen atom. Okay, or cation. Here sulfuric acid and hydrogen carbonate will give two molecules or two ions, two hydrogen ions. Okay, here next these examples will give three hydrogen ions. So on the basis of this we can come to know the basicity of acid is what? The number of H plus ion obtainable by the dissociation of one molecule of an acid is called acidity, is called its acidity. In other word, we can say the number of hydrogen atom replaceable by a base. Okay, when it will react with the base, so it will be replaceable by a base in a particular acid. It's called basicity of the acid. Okay, here in the chart, the next base number of OH minus obtainable or obtained from one molecule. So here sodium hydroxide, potassium hydroxide will give OH minus, 1 OH minus. Okay, calcium hydroxide, beryllium hydroxide will give 2 hydrogen atoms. So, and the rest of will give the 3, and here ammonium hydroxide will give the 4 OH minus. So from that we can come to know the acidity of bases means the number of OH ion obtainable by the dissociation of one molecule of a base is called its acidity. Okay, so you may have come to know about this acidity and basicity. It's very simple. Then next is the concentration of acid and base. Okay, now this is the last topic from this video. Till it only we will understand. Concentration of acid and base. Here you can see 2 beaker. Okay, in both beaker A and beaker B, the half means 1 lemon has turned into 2 half part, and each half part juice have taken in each beaker. And each beaker, now here beaker A we will take 10 ml water, and beaker B we will add 20 ml water. Now from this activity, the sour taste of the solution is because of the solute, and solute is what? Lemon juice. The quantity of lemon juice is the same in both the solution, yet their taste is different. Why? The solution in the first beaker is more. Solution means 10 ml, and solution of the B beaker is less. Okay, 20 ml. So here, yet their taste is different. The solution in the first beaker is more sour, and the one in the second. Okay, so from this we can understand, although the quantity of the solute is the same in both the solution, the quantity of the solvent is different. So ratio of the quantity of the solute to the quantity of the resulting solution is different. This ratio is larger for the solution in the first beaker, and therefore that solutions taste more sour. On the other hand, the proportion of the lemon juice in the total solution in second beaker is smaller and taste is less sour. So, the taste of foodstuff depend upon the nature of the taste giving ingredient and its proportion in the foodstuff similarly. So, all the properties of solution depend on the nature of solute and solvent, and also on the proportion of solute in the solution. The proportion of solute in a solution is called the concentration of the solute in the solution. When the concentration of solute in its solution is high, it is concentrated solution, while the solution is called dilute solution when the concentration of the solute is low, and that can be made by adding water. Okay, by adding water in solution, more and more we can make dilute solution of the particular solute. So several units are used to express the concentration of solution. Two of these units are used more frequently. The first unit, the mass of solute in a gram dissolved in 1 liter of the solution, means gram per liter. So G/L means gram per liter. The second unit is the number of moles of the solute dissolved in 1 liter of the solution. This is also called as the molarity. 1 mole, so molarity of the solution. The molarity of the solute is indicated by writing the molecular formula inside the square bracket. For example, NaCl in square bracket has written is equal to 1. It means The molarity of the solution of common salt is 1 mole. Understand here? So here we have finished the one part of this video. Thank you for watching this video. If you have liked by teaching, then press on like button and share this video with your friends. Student, watch this complete video and then only watch the part 2 of this chapter. Otherwise, it will be difficult to understand the part 2. Watch this video for at least 2 or 3 times. We will meet in the next video. Like this, till then, bye bye.